Algebra 1 students, welcome to your 9.6 notes. This is the last section of notes for the entire school year. We're going to take a look at the quadratic formula. There's really only one direction we can take this, the direction of working with effort, passion, and doing this right. So stick with me and let's learn the quadratic formula. Throughout this chapter, we've looked at different ways to work with quadratics, how to solve quadratic equations, and just simply, things like factoring, graphing, etc. But today we're going to look at a way to solve that works for any quadratic formula. The methods we've used before, like graphing and factoring and square roots, they work in certain cases, but in others they don't work quite as well. The quadratic formula, though, works for any quadratic. And so here we go, let's take a look at it. If ax squared plus bx plus c equals 0, got to be equal to 0, that's a key thing here, then x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now that formula might look a little bit tricky to you, but we have some ways to learn it, and you will need to learn it, by the way. One would be to learn it to the tune of Pop Goes the Weasel. It would be something like this. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Pretty good, huh? Now, some of you might be into older television shows. And if that's you, if you're into a show like, say, Gilligan's Island, you might prefer the theme from that show. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Pretty good. All right, so let's take a look at this. Here's an example of it. You can see, you can walk through what we've done here. Remember, we're in the form of ax squared plus bx plus c equals 0. Now in this case our a term would be just a 1, b is negative 5, c is positive 4. Now you'll notice here I have a positive 5, that's because the negative b is changing the sign of b to positive, and then I plug in my various values. Negative 5 times 2, and actually that says times 2, and clearly that's supposed to be squared. I didn't get my superscript on there very well. So negative 5 quantity squared minus 4 times 1 times 4. This would be 25 minus 16, which leaves us with a 9. So 5 plus or minus the square root of 9 over 2. We know that square root of 9 is just 3. So that's 5 plus 3 divided by 2, which would be 8 divided by 2, or 4. Or 5 minus 3 divided by 2, which is 2 over 2, or just simply 1. All right, let's do this. Let's take an example or two. Now, actually, even before we start doing them on our own, I want to look at this. Now, some of you may have been thinking, like, why not just do quadratic on every quadratic problem? Why not do the formula instead of having to learn this factoring and square roots and graphing, etc.? Well, here's a pretty brief example. Here's a quadratic on this page. X squared plus 9x plus 14 equals 0. I've solved it twice. On the left, I've used the quadratic formula. On the right, I've used factoring. Both methods work. Both give us correct answers. But I think you can see the advantage of using something like factoring when we can is that it's much faster, simpler, easy numbers to work with. Quadratic formula, it's not super complicated, but when you look at that, that is definitely worse than this. I think it's clear. So we still want to factor and know how to factor when we can. Although when you see an example like this, you don't have that option. So we're going to use the quadratic formula. It says x squared minus 8x equals negative 12. I need it to be equal to 0, so I'm going to add 12 to both sides. Now, our a term here would be the coefficient before x squared, that's 1. Our b is the coefficient before x, that's negative 8. And the c term here would be 12. So we can just start plugging these numbers in. X equals negative b, well that's just going to be positive 8, plus or minus the square root of negative 8 squared. And now when you think about it, when you square a negative, it just becomes positive. So I usually just neglect the negative right there. Minus 4 times A times C all over 2A. So here we go. We'll go ahead and simplify. This is 64 minus 4 times 1 times 12. That's 64 minus 48. So this is 8 plus or minus the square root of 16 divided by 2, which would then be 8 plus or minus 4 divided by 2. So finally, we'd get our two answers. 8 plus 4 divided by 2 would be 12 divided by 2, or 6. 8 minus 4 divided by 2 is 4 divided by 2, or just simply 2. Two solutions. Let's try another one. X squared plus 6x minus 17 equals 0. Now in this case, we know our A value is 1, B is 6, C is negative 17. So here we go. X equals negative 6 plus or minus the square root of 6 squared minus 4 times A term, which is 1, times the C term, which is negative 17, all over 2 times 1. All right, so here we go. Negative 6 plus or minus. Now this is 36 plus 4 times 17 is 68. So 36 plus 68 would be 104, and don't forget that whole thing is inside the square root symbol. And of course the denominator is just 2 times 1, or 2. All right, now here's where it gets a little strange in this case. 104 is not one of those nice numbers like a 16 that we had over here. As a matter of fact, when I punch in the square root of 104 on my calculator, I get 10.198. Okay, that is not a nice, pretty number. But here's what we're going to do. We're going to actually use our calculators. We're going to do two calculations. One of them is going to be negative 6 plus the square root of 104 divided by 2. And the other is going to be x equals negative 6 minus the square root of 104 divided by 2. And so we'll get two examples here. The first one, negative 6 plus the square root of 104, all divided by 2, gives us about 2.099. Where negative 6 minus the square root of 104, all divided by 2, gives us about negative 8.099. Interestingly, we could actually find those values if we graphed this, like on Desmos or on a graphing calculator. Those would be the x-intercepts. But we're solving by the quadratic formula, and that's our process. All right, why don't you guys pause the video and do number 3 on your own. All right, you can see my work here. I've plugged in b value of 5, changed the sign, then b squared minus 4 times a, and notice this time we actually have an a value. It's negative 2 times c, which is 7, all divided by 2 times negative 2. Inside the radical, and we're going to talk about this part of it in just a moment. This is an important part of our quadratic formula. We get the number 81, and so negative 5 plus or minus the square root of 81 over negative 4. And it just caught that I, Mr. Hale, unbelievably, not really unbelievably, believably, have made a mistake. Right here, that negative 4 turned into 4. No reason for that other than just human error. So we're going to fix it right now. Negative 5 plus 9 is 4, divided by 4 would give me negative 1. Negative 5 minus 9 is negative 14, divided by 4 is 14 fourths. That's positive 14 fourths, which is the same as 7 halves. Wow, that was a scary one. Almost missed my mistake. Almost. All right, here we go. Number 4. Let's do this one together as well. X equals negative b. Now notice here the b term is negative already, so I'm going to change the sign. Plus or minus the square root of 30 squared minus 4 times 9 times 25, all over 2 times 9. All right, now these numbers are getting a little bit bigger. I'm going to work inside that radical, and I'm actually going to use my calculator for this. I'm punching it in right now. 30 squared minus 4 times 9 times 25, and I get the number 0. Well, that's interesting. It doesn't matter if we add or subtract 0. It's still 0. So all we have here is 30 divided by 18, which would be 5/3. So folks, what we have going on here is a graph that touches the axis at 5/3, but it doesn't cross. We actually saw that earlier in this chapter. Perfect square trinomial is the situation there. And you can see that case right over here. So this slide right here shows you the 3 possibilities. We could have 2 solutions, none, or 1. Now, we're using what's called the discriminant. That's the portion of the quadratic formula that's inside the radical, the b squared minus 4ac portion. If b squared minus 4ac is positive, like you see right here, we would have 2 real solutions. In other words, 2 places where the graph crosses the x-axis. If b squared minus 4ac is exactly 0, that's the scenario we just saw, then you have 1 real solution where the graph is tangent to the axis. And sometimes you get b squared minus 4ac, the discriminant, to be negative. And as we've talked about, you cannot take the square root of a negative number. It takes us into imaginary land. We're not ready for that yet. So at this point, we'll just simply say there are no real solutions. So let's go ahead and use the discriminant to answer the questions you see here. Find the number of real solutions. Nice thing, notice it doesn't say solve. It just simply says find the number of real solutions. So let's do that. All right, so we're going to just simply do b squared minus 4ac, and this will answer the question for us. So here we'll have 5 squared minus 4 times 3 times negative 2, which is 25. Now this term right here is minus, and then 4 times 3 is 12 times negative 2 is negative 24. So it ends up being plus 24, which is just simply 49. Now it's nice to know that it's 49, but quite honestly, with these instructions that say find the number of real solutions, we need to know, is it positive, negative, or is it 0? And so in this case, we get 2 real solutions because the discriminant is positive. All right, let's take a look at this at number 6 together. Again, b squared minus 4ac would be equal to 6 squared minus 4 times 1 times 10, which is 36 minus 40, and we know 36 minus 40 is negative 4. Well, a negative discriminant tells me that there's no real solution. Because remember that when we find this discriminant, what we're talking about here is the number inside the radical. It has to be positive or perhaps 0, or we aren't going to be able to solve it. And now for our last example of the year. Again, we're going to do b squared minus 4ac. This allows us to find the discriminant. I'm getting emotional here. It's been a long year, a good year, but a long year, and we're wrapping it up, and it's hard to keep it straight. I'm joking. Okay, so anyway, b squared minus 4 times a here is 1, c is 36. So negative 12 quantity squared is 144. 4 times 36 is also 144. That means the discriminant is 0, which means we have exactly 1 real solution. Folks, you may be wondering, why is Mr. Hale playing this boy band music behind his video? Or some of you are saying, I'm not really surprised that he'd be a fan of One Direction. That seems about right. I don't like you people that think I'd like One Direction. However, there's a great video I want you to watch, and I will put a link right under